So this is a question where we are going to perform and interpret a hypothesis test. So in this question, the local gap owner wants to know if their average customer lives more than 28 miles from the store. So we are assuming that the null hypothesis states that the average customer lives 28 miles from the store. The local gap surveyed their customers and received 20 responses. Using the results from the survey, the local gap decided to assume that the population standard deviation from the distance of the store is actually 15.5 miles. And they conduct a hypothesis test to determine at the 5% significance level if the customers do live more than 28 miles away. This means that our alternative hypothesis states that we want to know if they are more than 28 miles away from the store. What kind of test is this? This is a one-tailed test. It's actually a right-handed test because it is more than. And that is because if we look at our normal distribution, we want to know if they're living somewhere above 28, not below, which makes it a right tail test. Now, in this section of the question, we want to find out what the test statistic and the p-value is given these values in the table. So the first thing we need to do is write out our equation. Well, the test statistic equation states that the sample mean minus the population mean all over the standard deviation divided by the square root of the sample size. Okay, so we have everything in this question. We have the sample mean, which is 28. We have the standard deviation, which is 15 miles. And we have the sample size, which is 20. The only thing we're missing is the sample mean. So we are going to go ahead and find this. So we go on over to our calculator. We've already entered all the values in our list. Every single value has been entered. Okay, double checking. All right. So we go to the home screen. And now we go ahead and find the mean. So we have our list. There's our L1. Scroll down to mean, enter L1, which is the list everything was in. Close parentheses, hit enter. There's our mean. Our mean is 26.4. Now we can plug that into our test statistic calculation. Minus the population mean. And make sure your parentheses are in the right place or you will not get the right answer. Divided by the square root of 20. Make sure your parentheses is outside of the square root. Hit enter. All right, this is our test statistic. So the test statistic is equal to negative 0.4616. Now, the last thing we have to do is calculate our p-value given the information we now have. So we found the test statistic. Now let's go ahead and find our p-value. Let's head over to our calculator. And for this, we're going to use the TCDF. Scroll all the way down to TCDF. So we're entering our test statistic, which is negative 0.46. And our upper value, we're going to use infinity. So we're going to simulate infinity by using positive e to the 99. Degrees of freedom are 19 because we have 20. And remember that the degrees of freedom is n minus 1. So now we also have a p-value. So we have determined that the p-value is 0.6749. Now, what do we do about our hypothesis? Do we reject or fail to reject? Well, let's take a look and see let's recap, right? We know that our p-value is equal to 0.67. And the rule says if the p-value is greater than 0.05, then we reject. If it's less than 0.05, we reject. In our case, our p-value is actually greater than, so we fail to reject. Failing to reject a null hypothesis means that at the 5% significance level, the data does not provide sufficient evidence to conclude that the average distance the customer lives from the Gap store is greater than 28 miles, which was our alternative hypothesis. Because if you remember, our null hypothesis said that the mu was equal to 28, and our alternative stated that the mu was greater than 28.